All right, so final exam review, day 5. This is the final day. We're doing questions number 45 to 55. Okay, so numbers 45 to 55. So for question number 45, we're evaluating the infinite geometric series. Okay, so evaluate the infinite geometric series. So for this type of problem, since it's an infinite geometric series, you know a couple ways that it is an infinite geometric series because of the fact that there's an infinity on top, okay? So that's kind of like a hint that it is an infinite series. And then the way it's written, right? 3 times a half to the n minus 1, that looks like a geometric sequence. So the formula for this, we actually did this yesterday. S is equal to a sub 1 over 1 minus r, as long as the absolute value of r is less than 1. Okay? So the main thing I want to do first is I want to test r, because if r is too big, then I don't have to do any work. Okay? So what is my r value in this problem? 1 over 2. And is it true that 1 over 2 is less than 1? Yeah, so since it is, then I do have to do work. If it wasn't, then I could stop and say there's no sum. Okay? So let me go ahead and use this formula. S equal to a sub 1, which a sub 1 is 3, right? So it's 3 over 1 minus r, which is half. Again, you can just put this into your calculator if you'd like, but 3 over 1 minus half is half. 3 divided by half is 6. So there's your sum. So always make sure you check that r value. That's the very first thing you have to do, okay? I'll even put a big circle around here. Because if that fails, then you're done. If it passes, then you have to do the actual formula, okay? So that answer is just 6. So you'll notice number 46. Am I going to have to do number 46? No, because my r value is 3 over 2, which is greater than 1, not less than 1. So for this one right here, r is equal to 3 over 2. The absolute value of 3 over 2 is greater than 1. Sorry, it is greater than 1, but I want to ask if it's less than 1. That's a no. So you're going to write either no sum or no solution, okay? Whatever they tell you to put, that basically says you can't add it. Okay? So that one we can't do because of the fact that the r value is too big. So those are the last 2 infinite geometric series problems. Okay, we didn't get to do those yesterday because we were only doing 11 at a time, so kind of stopped at the 11th one. We still had 2 more to go, but I mean, these aren't too difficult. Like I said, just know your formula, know what's important. The r value is important. Check it. If it works, do the work. If it doesn't work, then say you can't do the work. Right? No sum or no solution. All right, let me give you a little bit of time. I'm going to pause this just to write this out. All right, so let's go ahead and do this. How many events are going to occur? How many things are going to happen? It's 3 times, right? They told me I'm going to do this thing 3 times. Okay? Each time I spin it, how many options of colors do I have? 4. Now, on the next spin, am I still able to use the same color or not? Did they say anything about that? No. So that means I can use the same color again. So the first time I had 4 options, that means the next time I also have 4 options, and the next time I also have 4 options. Okay? So that's going to give me a total of, well, 4 times 4 times 4 is 64. Okay? So that's going to be my solution for this. So 4 times 4 is 16, times 4 is 64. Okay? So that's 47. By the way, any questions on this one? All right, 48, permutations. Okay? Permutations. Let me give you guys a little bit of time to write this one out. All right. So for this problem right here, they ask us if it's a permutation or a combination. Even though the order in which the numbers doesn't matter, right? It could start with the 9, it can end with the 9, but it does matter that you use all 4 numbers, right? That does matter. So since there is an importance to the way you write these numbers out, you're going to say that this is going to be more of a permutation, okay? I would say this is more of a permutation, but if you remember, these combination log problems didn't require you to do a formula. You just had to do 4 different settings, right? So how many options did I have for the first number? 4. Now the next one has to be how many? 3, right? Because if I happen to use a 9, I can't use a 9 again. So that means I only got 3 options. That means the next one has an option of 2 numbers and 1, okay? So 4 times 3, that's going to be 12. 12 times 2 is 24. 24 times 1 is still 24. So your options, total combination for that would be 24. So there will be a log problem, okay? So remember those. A lot of people didn't do well on the log problems on the quiz. So look at that quiz that I gave back to you guys. Look at this problem, right? You can look at the examples we did in class. So as you guys are writing this, let's just read this and let's see what you think. Is this a permutation or a combination? They say the student body of 60 wants to elect the president, vice president, and secretary. Is that a combination or a permutation? Yeah, this would be permutation because depending on who they pick, they'll be the president, vice president, and secretary, right? So let me give you guys a minute just to write this down, and then I'll come back. All right, so this is going to be a permutation for us. So they say a student body wants to elect 3 different people, right? Order matters. So we're going to do 60 permute 3. You punch that into your calculator, comes out to 205,320. That's how many different ways you can do that. Okay, remember you're doing 60 permute 3. So you're choosing 3 people, but it matters the order in which you're choosing. All right, any questions on any of the problems so far, 45 to 49, because we're going to move on to, I think, a different type of problem. Yeah. So anything on the permutations, combinations, geometric or infinite geometric series, anything like that? All right. So I do have to remind you a little bit here. So let me do that in case you forgot. So there are 3 definitions you guys have to make sure you know. You have to know that sine of theta is opposite over hypotenuse. Okay, cosine of theta is adjacent over hypotenuse. Remember, hypotenuse is always the longest side. It's the side opposite of the 90-degree angle. So in this picture you see right here, the hypotenuse is 5, okay? Because it's opposite the 90-degree angle. And then you got tangent of theta, which would be opposite over adjacent. Okay, so those are 3 definitions you guys should make sure you write down on your notes in case you don't know them already. You'll have to know them if you take trig, but for now, just make sure you know these. There's many more. There's cosecant, secants, cotangents, and inverses and all that stuff. And we actually do inverses here, so you'll see those. All right. They want me to find tangent of theta, okay? All right, so for this right here, we're going to have to find tangent of theta, right? Now, tangent of theta is opposite over adjacent, okay? Now, oh, here we go. So tangent of theta is opposite over adjacent, so we're going to want to use that. Now, this is my theta value right here, okay? This is theta. So the opposite side of theta is over there. That's 4. The adjacent side is here. Okay? Adjacent means next to. So if you notice, there's two sides that are next to that angle, right? But the number 5 is opposite the 90-degree angle. That means that's my hypotenuse. By definition, the side opposite the 90-degree is called your hypotenuse. So the other side, the one we don't have anything on, that's going to be considered my adjacent. Okay? So I'm going to write that down here. This is opposite. This is adjacent. The problem is I don't know what adjacent is. If I knew what adjacent was, then I can finish this problem really quickly. So I'm going to have to use a formula, right? A formula that you guys should know, which is the Pythagorean Theorem. Okay, x squared plus y squared equals, actually no, you guys don't use x and y, huh? You guys use ABC. So a squared plus b squared equals c squared. In my trig classes, we use x, y, r. So remember, C is your hypotenuse. A and B are your sides. And it doesn't matter which one you let be A or B. Just let the sides be one of them. So we'll let A squared just stay A squared, but B will make it 4 squared, and C will be 5 squared. Okay, so I got A squared plus 16 equals 25. If I subtract 16 on both sides, I get a squared equals to 9. And then I just got to take the square root. So a is equal to 3. It could be plus or minus 3, but since my a term is the measure of a length, it can't be negative. So now that I know that a is 3, now I can do my problem. So all of this was done just to set it up. Okay? So here's my answer. Tangent of theta is opposite 4 over adjacent 3, and that's it. Tangent of theta is 4/3. Now, if you're wondering to yourself, do I have to do it that way? I could swear I remember that right triangles, you have 3, 4, 5s, 5, 12, 13s. Yeah, if you remember the perfect triples, you can use that instead of doing the work. But if you don't remember, you're going to have to use the Pythagorean theorem. Those are called Pythagorean triples. The 3, 4, 5 triangle, the 5, 12, 13 triangle. Those are some that exist in 90 degrees that are like perfect numbers. Any questions on this one? Remember those 3 definitions? Don't forget your Pythagorean theorem, right? I'll kind of highlight that for later for you guys. But this is one of those things that you guys have to remember in order to do these problems. You may not always have to use it, but you may have to use it. Let's do another one like this. So they want sine of theta. Okay, now sine of theta is opposite over hypotenuse. Let me label my angles, okay? So here's my angle, not my angle, sorry, my sides. There's my angle. So opposite that angle would be a 5. The hypotenuse side is not labeled. That's hypotenuse right there. Okay, so that leaves the radical 30 as my adjacent side. So according to my definition, sine of theta is opposite over hypotenuse. I have opposite, I don't have hypotenuse. Okay, so let's figure that out. Let's do the work here. A squared plus b squared equals c squared. I know 2 sides, I don't know the hypotenuse. So 5 squared plus radical 30 squared is equal to c squared. 5 squared is 25. Square root of 30 squared is 30. That's equal to c squared. 25 plus 30 is 55. And if I take the square root of both sides, I get the square root of 55 is equal to c. Okay, so that's the square root of 55. Are we okay with that so far? Remember, this is all Math 1 stuff, so this shouldn't be like mind-blowing unless you fell asleep during these lessons last year. Then maybe it's brand new, but hopefully you didn't. But this is a very common formula. Don't feel scared in using it. Use your calculator if you have to. So now all I got to do is do opposite over hypotenuse, right? Sine of theta is opposite over hypotenuse. Are they going to want you to leave your answer like that? No, right? So you're going to have to rationalize. Now, let me just double check. I think on your calculator, if you literally type 5 over square root of 55, if you're using one of the calculators that you guys borrow from me and hit enter, it actually simplifies it for you. It puts square root of 55 over 11. So it does it for you. But just in case, right? Always good to do this by hand, just in case. You rationalize this. You multiply top and bottom by the radical on the bottom. The top becomes 5 radical 55 over, well, radical 55 times radical 55 is going to come out to 55. Okay? You can do that on your calculator. And 5 over 55 will reduce to 1/11. So your answer is radical 55 over 11. Again, you don't have to do this by hand. I literally just typed it into the calculator and it did it for me. Okay? So you guys don't have to do it by hand. You can just let the calculator do the work for you once you get it in a fraction. Okay? We're almost done. 52, 53, 54, and 55. And then we're done. Okay. Find the measure of the side. Okay, find the measure of the side. They gave me an angle of 30. They want me to find x, and I know the side 10. Which trig function will help me with this? Let's label it. I know this is my hypotenuse. X is opposite or adjacent to angle 30? Opposite, right? That means this has to be adjacent. So they gave me these two pieces, opposite and adjacent. Which trig function do I use? Say again? Tangent, yeah, tangent. Tangent of my angle, so I'm not going to put theta this time, I'm going to put 30 degrees, is equal to opposite, which is x, over 10. To get x by itself, all I have to do is multiply by 10. So I'm just going to multiply by 10. That gives me 10 times tangent of 30 degrees equals to x. And then I'm just going to get my calculator, okay? And we're going to want to make sure you're in degree mode. This is in degree mode. I'll try to make sure I remember to tell you guys that. Because this says tangent 30 degrees, so you want to make sure it's in degree mode, okay? We're going to do 10 times, and then I'm just going to type in tangent of 30, hit enter, and it gives me 10 radical 3 over 3. Now, if on the test they give you a decimal, remember there's a button that looks like this, and you can always ask me during the test, but there's a button that looks like that, and it'll give you 5.774, let's say, if you round it, okay? I don't think they're going to do that, but if they do, just press that button. That gives you the decimal, okay? So that's a lot easier, I think, than the previous one because we didn't have to use a secondary formula to find any, okay? But we do have to use our calculator for sure, okay? So when you take trig, you'll be able to get that answer without it because you'll know that tangent of 30 degrees is radical 3 over 3. And then if you just multiply radical 3 over 3 times 10, you get 10 radical 3 over 3. So you'll know how to do that by hand when you take trig. Okay, you don't need a calculator for that. Here's another one. Find the measure of the side. After this, we got 2 more problems where you got to find the angle. So we're going to be doing inverse functions. And again, you're going to count on your calculator to help you do that. So all of these triangle ones, you're probably going to want to use your calculator for most of them to do all the work. So let's label our sides. Remember, always start with your hypotenuse. That way you can find the easiest side, I would say. That's usually the easier side, your hypotenuse. Now, the angle that I have is 37.2. Which side is my opposite, the 2 or the blank side? Which one is opposite? The 2, right? This is opposite the angle. That means this has to be adjacent. Okay? According to what's given to me, which trig function should I use if I have opposite and hypotenuse? Notice adjacent is blank, so I'm not even going to use it. That's a sine function, right? Opposite over hypotenuse. So sine of my angle, 37.2 degrees, is equal to 2 over x. Now, in order to do this, I'm going to have to get the x out of the bottom. So I'm going to have to multiply the x over to the other side. So I did one of these because these are considered the challenging ones, and you are going to have one of these on your test, okay? So when you move the x over, you get x times sine of 37.2 degrees equals to 2. Now, sine of 37.2 degrees is just a number, any number, okay? Just think of it as any number. So let's just pretend it was 10. So you have 10x on the left side. So wouldn't you divide that out, right, to get x by itself? So if it was like a 10x on the left, you would just divide by 10, right? That's all I'm going to do right here is I'm going to divide both sides by sine of 37.2 degrees. I know it looks weird, but guys, sine of 37.2 degrees is just a decimal. It's just a number. Okay? So that'll cancel. And then I'm just going to do 2 divided by sine of 37.2. And that gives me 3.3. And that's my answer. Okay, so 3.3. It's actually 3.3079, but usually they want you to round to the nearest tenth or hundredth. If it's hundredth, then it'd be 3.31. But we'll just go 10. So this is going to be the tough one of the two, finding the sides, because your x value or whatever, y value, whatever the letter is, will end up on the bottom. So you're going to have to move it up. Okay? Last two. Finding the measure of each angle. And this one truly is calculator based. Okay? So according to the angle, okay, theta is down at the bottom. Which one is my hypotenuse? Which one is my longest side? 13, right? All right. So which one is my opposite side? Is it 12 or the blank one? The blank one, right? So this is opposite. That means this has to be adjacent. Okay? Notice I have adjacent and hypotenuse. Which trig function do I use? Cosine. So I'm going to write cosine of theta is equal to adjacent 12 over hypotenuse 13. I got to find theta. So I don't know if you guys remember, but to find theta, we're going to get the cosine and throw it to the other side. And when you do that, it becomes cosine inverse. And there's literally a button. Well, it's a shift button, or yeah, second button. But right above cosine, if you hit shift cosine, it says cosine inverse. Okay? And then you're just going to put 12 divided by 13. And it gives you 22.6. So 22.6 degrees. And that's it. All right, so there you go. These aren't hard. You just got to make sure you know how to do them on your calculator. All right. So find that function, practice it. If it's not coming out to that value, it's probably because you're in degree mode. You're in radian mode, not degree mode. So you usually got to go into your settings and fix that. If you have a calculator that is yours, let me know and I can check it before you guys leave today. So here's one more. Find the measure of each angle. So I have theta there. Which one is my hypotenuse? 3, 4, or blank? The blank one, right? This is hypotenuse right here. Which one is my opposite, 3 or 4? The 3. That means that 4 is my adjacent. Notice they gave me opposite and adjacent. Which trig function am I using? Tangent, right? So tangent of theta is opposite. That's 3 over adjacent, which is 4. We want to solve for theta. So you're going to throw the tangent to the other side and it becomes an inverse. And then from here, you're just going to go to your calculator, type in tangent inverse of 3 over 4. It gives me a 36.9 if I round it to the nearest 10. So 36.9 degrees. And that's it.